We're live now, but
Sorry.
what I say we just talk about that next week.
Sure.
Yeah.
Okay.
So sorry about that, guys. My stream just froze. I don't know why it does that. I think it's like every time that I open up a window share and the collab cam, for some reason it just freezes. But I need a better computer. That's why, the super chats really, really help. I need a better computer to be able to bring you guys better content and not crash every time I turn around. So that would, yeah, that's one of the things that, uh, yeah, donations help and tips and all that. So I guess let's just, do you want to keep like talking about the flat Earth? I mean, that is
We can
the
talk about that.
topic,
Sure.
yeah. I didn't know what else to cover while you were gone. I figured like on my own I can just do this series of flat Earth like
Sure. No, that's okay. We can
topics.
do it however you want. I have my own theories about that, and I know the guy was going quite my point. I was watching the podcast, and I definitely took some exception with one of some things he said because he might have misrepresented a few things or misunderstood a few things. I'm sure he's a nice guy, but I think he might just have missed a few like details. And we can go through some of that if you like, or we can move on to the next thing. It's up to you.
We can go on to another video. Let's see. Let me get this fixed up. I hope I don't. If I crash again, guys, we're just going to end it for tonight. That's if it crashes again. And then we'll just pick up next week where we left off. And we'll talk about next week will probably be the Hollywood thing, by the way. So we've got some interesting takes on we're going to do a deep dive on Hollywood and the chaos in Hollywood and all the evilness in Hollywood next week. So guys, get prepared for that. It's going to be a good one.
I think we have a few things coming up the next few weeks that you should be ready for. We're going to start dropping some hammers on stuff. So
Oh, really?
hope they're ready for. Yeah, I went through it. I went ahead and went through some of my old files, stuff I used to do, people I used to work for, and I figured I would gather some of those things. And when I drop it on you, you'll be very surprised, and you're going to want to drop it on them.
Yeah. Let me
You'll see.
turn you up a little bit. Why am I not able to hear you that well?
Maybe it's mine. That's it. All right, turn it up.
I can hear you. It's just not as loud as it usually is.
How about that? Is that better?
Yeah.
Perfect.
All right. So let's go to the next video. We're just talking
Isn't
about
the ocean
videos.
enough proof that the Earth is flat? I mean,
So,
we see
a couple
oceans
things if I may
stretching
add
for
before the video
miles like a
starts.
continent.
Um, I know that people have made a few claims here and there, and I just want to go through and maybe take care of some of the easier ones. That'd be good. Um, for example, claim number one: you can't see curvature, so it's flat. Wrong, dipshit. You're 6 feet tall with dog shit eyesight, staring at a 24,900 mile circumference sphere. Of course, you can't see the curve from the balcony. You're an inbred astronaut. Of course, but guess what? Commercial pilots at 35,000 feet see it every goddamn day. Cargo ships disappear hull first over the horizon. Display that on your pizza Earth. Yeah. So, because on a flat plane, they just get smaller and smaller until they vanish. But they don't. The bottom disappears first every single time. That's the curvature. You just like we don't have a sunrise all of a sudden like that when we flip a coin, and we would have a sunrise that would say blanket all of America at the same time. We wouldn't have a time zone something like that. Claim number two: NASA faked all the photos. Oh, really? So the Soviet Union, China, India, Japan, Europe, SpaceX, Blue Origin, and every amateur rocket guy with a GoPro, all on the same conspiracy for 70 years. You think the Russians wouldn't have screamed fake the second Apollo 11 photos dropped if they weren't real? They hated our guts. They would have loved to humiliate us. They didn't. So I think that's safe to say that was all nonsense.
Unless,
So okay, go ahead.
could it
Unless we're
be?
working together.
Could it be that all the elites? Okay, so you've got an elite running the United States. You've got an elite running the other countries, correct?
Mm-hmm.
What
Yeah.
if they all had one rule, okay, we don't let the cover up of this actually being a flat Earth out. So if you want to do your moon trip to Earth, we're going to back you. We're going to say, oh, it's real. Could that be a possibility?
Um, no, because everybody's greedy and everybody wants power. So if they could have embarrassed us, they would have, I think. But let's say it's possible, right? Let's say, um, like gravity is a lie. Things just fall because density, right?
Well,
And why does
gravity's never been proven.
I mean, how would you like me to prove it? I could. There's a couple of different ways I could do it. I could drop my phone on the floor right now, and it drops it about 9
Scientific, it could be something else that's doing that. It could be a magnetic pull that's doing that.
Okay. How about we take a plastic object, right? It's still going to drop. There's no metal for it to be magnetic. So ferrous metals.
It could be what's those things? They're saying, okay, so they're saying a vortex. It could be a vortex at the true North Pole. They're saying there's a vortex at the true North Pole, and where the black rock is, that goes like inside itself. It goes like this, and that's what caused. Okay, so let me ask you this: the moon is supposed to cause waves and tides, right, on all water. Well, why doesn't it do that on lakes?
It sure does. Why not? Why wouldn't it? Of course it does.
It doesn't.
I mean,
There's no waves and
lakes.
tides on lakes.
Sure does. Lake Michigan has waves all the time. Actually.
Not with
If
waves.
yeah, even and here's the thing: it's so wavy that when it starts to freeze like it is now, you'll see frozen waves. Believe it or not, I'll take you out there and see sometimes. I promise.
But there's not like a pull tide like currents in the ocean. There's not.
Mhm.
They're not like that in the
So
lakes. Why not?
well, the volume of the lake is like usually a lot smaller when you compare it to the ocean water, right? The ocean is like 70% of the Earth's surface, and as
Correct.
pool, it's pulling on that just collectively, right? So when it pulls on a lake, it's also pulling on the ground that surrounds the lake, right? So that ground has a little bit more resistance. Now it's not going to get uprooted and just join the lake as far as like moving up too high, but like it does have an effect. You just can't see it. It's immeasurable. It's like imperceivable. Imperceivable. That's what it
You
is.
just can't see it. Okay.
Well, sort of, yeah. I mean,
It's
you
what
know, if you
it's
measure
just
it, like, I tell you
something
what,
I
if
hear
there was
all
a
the time.
if there was a seismic device, you would be able to see it on the meters, but our eyes are not able to perceive it because it's such a small movement. Just like we can't tell, but the moon is actually getting further and further away, right, from us. We just can't perceive that. It's like a couple inches a year. It's not very much. Hard to see it.
Okay. Okay. Let's see.
Just trying to help you out.
I
Um,
understand you. I
Gravity
understand
is
you.
strong enough to hold oceans.
Here we
um,
go.
Make
Here
a
we go. Here we
simple
go.
airplane lift hundreds
okay.
of tons into the air. Let that sink in for a second. Billions of gallons of heavy water supposedly cling to a spinning ball, but a jet engine can slice right through that same force like it's nothing. Yeah, something doesn't add up. And today, we're peeling that onion layer by layer. So here's the thing. We've all been told gravity is this invisible superhero that holds down oceans, buildings, cars, you, me, everything. But when you stop and actually think about it, the story starts to wobble. If gravity is powerful enough to pin trillions of tons of water to the side of a globe, why do clouds float? Why can a butterfly dance upward without being crushed? Why can a massive steel airplane weighing hundreds of tons
Yeah.
just defy that pull and soar effortlessly? Now they'll say it's aerodynamics, it's
Oh.
lift, it's thrust. Sure, that's the textbook explanation. But if lift beats gravity so easily, doesn't that mean this invisible force isn't as all-powerful as we've been led to believe? Maybe what we call gravity is just density, buoyancy, and equilibrium, working together in a world that's not spinning through space, but sitting still,
Mass.
perfectly balanced. Think about it. When something is lighter than the air around it, it rises. When it's heavier, it falls. No magic. No mysterious pull from a core 4,000 miles below your feet. Just simple, observable physics. Right here, right now. That's why ships float, smoke rises, and an airplane, when it reaches the right balance of pressure and thrust, can glide through the air like it's swimming in a sea of density. not fighting an invisible giant.
Yeah, how do you explain that? It's the density of the air.
Mass.
Mass. Okay. Let's see what
I'll
else
go
we got.
through that as soon as he's
Imagine-
done.
Huh?
I'll explain as soon as he's done.
Okay.
In the world not as a globe, but as a level plain, where air and water find their natural place. The oceans stay flat, because that's what liquids do. They find their level.
Delay here.
The plane takes off not by beating gravity,
I'm on a bit of an audio
but
delay.
by
I'm trying to fix that
mastering
now.
the flow of air.
You can't hear it, right, on your end?
I could hear it through the feed on YouTube.
Okay.
So I'm a little late, yeah.
Let me see if this fixes that. Because right now I'm sharing your box with you, but let's try this and see if it works better. Dun, 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 dun. Oh, I'm not sharing anything with you right now.
Nope.
Let's do... Boom. Now you should be able to see it.
Adjusting pressure. The real question isn't how gravity holds oceans and lets planes fly, but why we stopped questioning what we were told in the first place. Stay curious. And if this made you pause for even a second.
So, alright. Can you hear that, by the way?
I can now.
Let's hear it.
Oh, sorry, I was going to listen to. Okay. Let me make sure. No, actually, I can't. Sorry, but I did hear it. It stopped. It seemed like.
Oh, well, it's at the end. Like, it's like if you learned anything from this video, yada, yada, yada. But I can play another one.
Sure.
Okay, let's do that.
Our level Earth plane has long been
I
ridiculed
promise
as
by next
being
week
a
we're going to have all
crazy
these
conspiracy
issues
theory
worked
and an
out.
ignorant, unscientific worldview.
Promise.
But the facts of the matter are far from what you have been told. When thoroughly examined and diligently researched with an open mind, any skeptical, critical thinker will find it is actually the spinning spaceball Earth, presented by government space agencies and taught in schools, that is truly ridiculous and unscientific. Proof number 1. Common sense. It cannot be overstated or overemphasized. The most important thing to realize, and the most obvious way to know we are not spinning on a ball, is our own common sense and lived experience. We have always, and will always, experience ourselves as living right side up, on a non-rotating level Earth, with the sun, moon, and stars revolving over and around us. This is common sense, and what everyone in the world personally experiences, every day of their lives. We are taught to believe otherwise, however, many things completely contrary to our own common sense and experience from a very early age. We are told that we live on a sphere, where people on the other side live with their feet above their heads, where rain falls upwards, trees grow upside down, and the sky is lower than the ground. Truly, the idea that people are standing, ships are sailing, and planes are flying upside down on certain parts of the Earth, while others are tilted at 90 degrees and all other impossible angles, is an utter absurdity and an insult to common sense. In fact, common sense is the first casualty of globe belief. Proof number 2. Water. The natural physics of water is that once contained and undisturbed, the surface will always remain horizontal.
Water always needs to be in a container. I said this before you joined. Well, in a flat Earth, we have a container with the firmament. This is just something to keep in mind, by the way. And so, without that, on a spinning ball, there is no container, so water would fly everywhere, correct? Something to think about.
This fundamental physical property of water is why it has been used as a leveling tool by builders and engineers for millennia. Whether in a pond, lake, or ocean, the surface of the water at rest
So you
always
gotta remember, the
remains
mass of
level.
the Earth is much more than just the ocean, right?
Do what?
Sorry. Well, no, because the mass of the Earth is much more than the mass of the ocean itself, right? You have the core of the Earth, and then you have the other layers before the ocean there, right? Let me turn this down just a little bit. So the mass of the Earth is much larger than the ocean's mass, and gravity is specifically like the amount of mass. Sorry, the
No,
amount
I
of
get
mass
what
the
you're
Earth has.
saying. Things pull
Right.
towards the bigger.
Yes, exactly right. But let me see if I can help with this. So the force of gravity is the mass of one object times the mass of a second object times the actual like um, distance between them, right? So like you have, um, yeah, so you have the grass of the, so your gravity is the mass of one object times the mass of the other object, okay, and then divided by the radius squared, right? So the bigger an object is, the more pull it's going to have. So for example, the size of the Earth is like say mass times 10, right? And the size of the ocean is say mass times 1. Just because it's bigger than the ocean, it's going to attract the pull of the ocean towards the Earth's surface, right? And the Earth is so huge. That's why, for example, if I'm standing straight up, right, in say Chicago, right, and a guy in Brazil is standing straight up, right, we're still pointing at different angles. On that surface of the ball, we're still pointing straight up because our feet are touching the ground, and that's what's keeping us towards the ground. I know this is really bad explanation, but that's kind of what it is. Everything's going to go towards the center of that mass with gravity.
So why is there not water at the center? Like, why does not all the water on the globe, sorry, uh, go towards the center of the Earth?
Well, because
Why
the
is
Earth
it
is like
spread
the
all
Earth
the
is
way out?
sure the Earth is round, right, and so it's going to spread out all over the surface of the Earth, right. Now it's not perfectly round. There's divots and grooves and things like that. And that's why we have oceans. Right? So it fills in the oceans, but at some point we run out of enough water to fill the entire surface. At one point, it did cover the entire surface of the world, right? But the tectonic plates shifted, things moved around, and it came to a point where because they shifted together, the matter that was like rock formations and stuff like that came together and pushed up out of the water. And that's where we have like continents. Right? When the volcanoes erupt, they will spew out hot liquid magma that comes from the center of the Earth, and that's more rock formations basically. Those elements will spread out across the ocean surface, cool, and then be left there as like an island, for example, like the Hawaiian Islands. So everything's always pulling towards the center of the Earth. So wherever you're at, you're going towards, you're landing on the ground because it's always pulling towards the center of the Earth. If you dug a hole in the ground and then you stepped over that hole, you wouldn't just hover. You would fall into that hole, right? There's the center of the Earth.
Hmm.
That makes sense? Hopefully it
It does, but not the way I view it.
does. Okay. Okay.
It does for a globy, but that's what we were taught. So, yeah.
The globy, is that
Doesn't
what they
have
call
the
us?
What?
They call us globies now? Is that the
Globies or
vernacular?
globers or yeah, globies. But we're called flurfers, so
Flat Earth? Okay, surfers. I never heard that one before. That's
I
interesting.
mean, honestly, y'all have the better name, but at least I'm not on a spinning ball. But all
I'm okay
right,
being on the spinning ball. I'm really okay with it.
let's continue this video. Let's see what
Sure,
other
sure.
proofs they have.
ability to hold and display convexity, or any shape whatsoever upon its surface. This fundamental fact of reality is easily demonstrable and empirically verifiable.
What about the water in a container theory? Water has that's a universal law. Water has to be in a container, correct? To survive or to exist. It's got to be held in a container.
Yeah, it's not a solid mass, right? It's a mass has three levels of density, right? So the more the more spread out the molecules are, the less mass they'll have at the center, right? So you have say a gas, for example. The molecules are very spread out, and that's why it's in a gas form. It doesn't really come into a shape exactly, and it will fill up a container it's in too, right? And as you bring those molecules closer together, you have a liquid form of matter, right? So like water, for example. So you have ice, water, and then water vapor. Water vapor just goes up in the air like steam. Water itself will fit into a container because it is liquid, and the molecules are a little more dense, but not so dense that it stays hardened. But when you bring the molecules even closer together and you form ice, for example, it will stay in that format, whatever shape it was in when it was frozen, because it is so compacted that it will fill that shape out, whatever object it's in, just like the Earth's surface.
Hmm. Maybe. Oh, we
Mm-hmm.
have a comment. What did they say? Where's the chat? I'm so sorry. I need to
Uh,
pull up the
listen,
chat
if
box.
you have cats, you know that water certainly does not have to be in a
I
container.
can't see. I gotta get it bigger.
Victoria, you are Victoria.
You're our
It's okay.
pretty much basically our first chatter, so
Hmm.
if you I can't read it. Let me pull this over. There we go. She says, if you have cats, you know that water certainly does not have to be in a container. That's funny. Yeah, and that's true. But I had cats like all my life, so yeah, I get that. But I don't know. I mean, no, I'm not gonna ignore you. I'm glad that you're pitching in. But I don't know. For me, it makes sense because I don't know. Like, if water is held in with a firmament, that's a container. It's not sloshing out all over the place. If it was on a spinning ball, water would be all over. Like, it wouldn't even be like the Gulf, or it wouldn't be, part of an ocean. I don't know. Just that's what makes sense in my head. Let's continue with the video.
Viable, but completely at odds with what we are told about the globe. For Earth to be globular, and over 70% covered in water, the oceans must somehow be curving around and sticking to all sides of a rapidly spinning ball suspended in a vacuum. It is simply impossible to make water behave this way, as anyone can experiment for themselves. Bodies of water will not stick to the underside of a ball, and cannot display or hold convexity or any other shape upon their surface. Proof number 3. Fake photographs. One of the main reasons the average person believes the world is a globe is because of the globular Earth images and video footage provided by NASA and other space agencies.
NASA says they admit pretty much all of their videos and pictures of Earth are CGI.
Hundreds of such pictures and thousands of videos featuring a globe Earth are freely available on the internet. Yet most people never critically examine them with a skeptical eye. From the earliest photographs to the latest live streams, NASA and the world's other space agencies continue to be exposed for their Hollywood-style trickery. When conscientiously compared, contrasted, and investigated for inconsistencies, it turns out every single image and video showing a globular Earth has been manipulated in some way. All globe videos, for example, are achieved using either a fisheye lens to curve the horizon or created completely through CGI technology. As for the hundreds of supposed photographs available of the globe, NASA readily admits that these are computer-generated composite images and not actual photographs. If NASA and the world's space agencies could provide real, legitimate photographs and videos of a globe, they most certainly would. So the fact that they continue producing and pumping out nothing but fisheye fakery and CGI cartoons is strong evidence that Earth is not what they claim. Proof 4. Long-distance photography. We are consistently able to observe objects at incredibly long distances, far beyond what we...
Yeah, so let me ask you, Godfather. If you are standing on a shore and you look out in the ocean, millions and millions, or not millions, but a long way out, like hundreds of miles, okay? And you zoom in, you can see the bottom of that boat. You can't see it with your naked eye. No, it looks like it's like floating on the horizon. Even so, explain that.
One more time, sorry. I'm looking at a boat. I'm looking at the ocean. Sorry.
So if I'm standing on the shore and I'm looking so many miles out, and I zoom in with like by my naked eye, I cannot see the bottom of that boat. But if I zoom in with a camera, it's there. Explain that.
The bottom of the boat? Wait, if you zoom in, you'll see the top of the boat first.
If I zoom in, I'll see the bottom. Like if I zoom in, like if I have a camera and I zoom in on the camera, the whole boat will appear.
Not at once. It'll still... So like when a car's coming down the road, right? You'll usually see the top of the car
Yes,
first.
at once.
At once? Okay.
Yes.
If you're only if you're close up. But if you're far away, the first thing you see is the top of the car, right?
Okay, so even so, let's take your logic. You know how you look like way out there and it looks like the bottom of the boat is gone and it's just floating there?
Yes.
That means it's straight symmetry.
Not exactly. So take, for example, let's say we're on a curved surface, right? Let's say my hand is, let's take this, curved surface. Let's say you're standing right here, right? and the boat is over here on the side, and it's coming over. The first thing you're going to see is the top as it's coming around the curved surface. And as far as the water in the container thing, here's an experiment you can do at home. Take a bottle of water, drink half of it like this. Right? As you move the bottle, the water will move with the bottle, right? Now take a piece of rope, tie it to the front of the bottle, and then spin in a circle. The centrifugal force, gravity, will push all of the water to the back of the bottle, and the front of the bottle will be completely empty. Why? Because the force of gravity pushing the water again when you're spinning around, just like the Earth spinning around.
Yeah, but that can also be explained by the magnet at Black Rock for the flarfers.
But if I'm spinning this bottle here, and you're spinning that bottle where you are, say in California, right? It's always going to flow towards the end of that bottle, right? If there is a magnetic vortex, the water would always be going towards the vortex, not towards the end of the bottle. If you're spinning in a circle, I'm spinning in a circle, or in two different points of the Earth, they should all be flowing towards the vortex.
Oh, yeah, I see what you're saying.
Yeah.
Yeah, I'm going to have to get back with you on that one.
And while the government might lie to you, I would never do that to you.
I'll have to get back with you on that one. Oh, I will, and I will.
If Earth was actually a globe of given proportions. By inputting the observer height and distance viewed into
Okay,
an Earth
so watch
curvature
this.
calculator, it is easy to check how much a target should be obstructed on a globe Earth. In Genoa, Italy, clear days reveal the distant island of Elba, 125 miles away. If Earth were a ball with a 25,000-mile circumference, Elba should be concealed behind over a mile of curvature, making it forever invisible. In recent times, people have been filming using infrared zoom cameras at high altitudes to capture lakes, mountains, and other landmarks up to an incredible 1,000 miles away. If Earth was really a globe, the size we are told, many of the landmarks photographed would be hidden behind upwards of 70 miles of curved Earth. Proof 5. The horizon. The horizon is always perfectly horizontal, 360 degrees around the observer, regardless of altitude. All amateur footage captured from balloons, rockets, planes, and drones at maximum altitudes of over 20 miles, without using fisheye lenses, consistently shows a completely flat horizon that remains at eye level. Only in NASA and other space agency footage does the horizon ever curve or appear below the observer's eye level. In the heliocentric model, the horizon is claimed to be the physical curvature of their globe, and the reason boats receding from a shorebound observer disappear from view. This was originally presented as one of the alleged proofs for a globe Earth by Aristotle, and is still echoed by believers today. However, with the use of modern zoom technology, we now know that the horizon isn't a result of the physical curvature of a globe, and those boats can be
That's what I'm
zoomed
talking
back
about.
in full view.
That zoom in right
This
there.
is because the horizon is not an objective physical phenomenon at all, but rather a subjective optical phenomenon based on an individual observer's perspective. If the horizon was actually the objective physical curvature of a globe, then objects receding beyond it could not be zoomed back into view, and it
Exactly.
would remain fixed as an observer ascended. This proves the horizon line is not some objective point of curvature on a convex Earth, but rather the subjective vanishing line of perspective from a given observer's point of view. Suffice to say, these 5 points are just...
So, you see what I'm saying with that though? Like the further you're out, the more you zoom in, you can see, like when you zoom in with that camera, you can see the bottom of the boat, which is supposed, the whole boat is supposed to be invisible if there was curvature.
Except for space is curved.
Okay. Let's go back to the last couple things, and we'll go through this one by one. So, the Earth is 24,000, like the video said, 24,900 miles around. You're like 5'9" off the ground, right? The horizon is 3 miles away, and you're looking at a patch of a ball the size of a dinner plate, right? From 2 inches away. Of course, it looks flat. And anybody who tries to argue is basically just smooth brain goldfish. Now, climb your scared ass up to a 40,000 foot like surface, right? Like a plane, like in a plane or on top of a mountain, right? or 12 miles out, 12 miles high up, that high of an altitude, right, in a balloon, right? Suddenly the horizon drops away on all sides, and you see the curve. It's really obvious, right? Think about it like this: if you stare at the ground right now from where you're at, you're going to see the floor in front of you, right? But if you climb to the top of your roof or your house and you look at the ground, you're going to see a whole yard, not just that little small surface in front of you, right? And the higher you go, the more you're going to perceive that, right? So suddenly the horizon drops away, and the curve is obvious. So you also triple the visible distance. So ships, cities, mountains that were hidden behind a curve magically appear exactly like they're coming over a hill. That's not perspective. That's not refraction. That's just the curve of a fucking globe. Um, Anyone with a $200 weather balloon and a GoPro could prove that, right? The higher you go, the more of the ball you'll see. Flat Earth can't explain that ever. End of story, right? Now, as far as the zoom myth, right? Bro, I zoomed and brought the whole shit back. Curve is fake. Okay, so here's the thing about that. So whoever's following their Nikon to the point where they think they can, zoom in and they're going to call it fake. Zoom doesn't bring back shit that's physically hidden behind a 200-300 foot like wall of water. It just makes that part of it still visible, bigger. You know, the bottom half of distant ships and oil rigs is gone long before you even pick up the camera. Right? You zoom in, you just magnify the top that's still peeking over the curve. Right? If it's over the other side of the curve, you won't see it at all. You didn't restore the hull. You didn't crop the photo like an Instagram thought. Right? If zoom actually flattened the curve, then every single sniper on Earth could shoot 150 miles instead of 3, right? But they can't. You can ask any sniper that. Because physics doesn't give a fuck about 80 optical zoom, like, that's it. Yeah. So take my word for it, champ. It just doesn't work that way.
Mm. Okay.
So,
Okay.
anyways, when you zoom in, you're not bringing it back. It's just called, you're changing perspective. You're changing perception. So,
Shouldn't you always see all boats if the Earth was flat? I think you do not see anywhere near far enough if it was flat.
oh, is that a YouTube comment?
Hmm.
Let's see. They're right. They're correct.
Hmm. Okay. I'm taking this stuff in, what
Sure,
both of you are
absolutely,
saying,
absolutely,
but I will have my answer to
absolutely. No
you
problem.
because, like, it still doesn't make sense to me.
So, for example, when I take my sailboat on Lake Michigan here in Chicago, I can't see the Michigan coastline. I can see the Indiana coastline, but I can't see the Michigan coastline because it's just that much further out. Now, I start sailing a couple of miles out, then I can see
How
it.
do you know that you can't see the coastline? Have you zoomed in with a camera?
Binoculars, yeah,
Mm.
and they're pretty good binoculars. Now, I get an even stronger like lens, but it's still going to fight the curve of the Earth, and I won't be able to see any other side until I get closer.
But what if you did see it? Then what?
Okay. For example, when you take the highway to Chicago from Indiana, right, and you're going across that Skyway Bridge, the very first thing you see is the top of the Sears Tower because it's the tallest building. Then you see the Hancock. Then you see the AI
That's the
building.
way our perception views it, though, because our eyes are round. It's
Sure,
just our
sure.
perception. It's gonna be that way. If our eyes were flat, we would see the
Hmm.
whole thing.
Okay. But like if you're looking at this bottle, right, you can see the whole bottle, right? If I go further away, you can still see this whole bottle, right?
Because of
But
our,
if I was,
it's just the way our
but
eyes
but that's because
are.
I'm holding it right in front of you. But if I put it on the ground and I moved it away, right, the further away it gets, the less of the bottle you're going to see. That makes sense.
It makes sense, but I still think it's got a lot to do with perception, the way that we view perception.
Okay. Okay.
And I could be
Um,
wrong, but that's what I think.
Perspective versus obstruction, right? So flat earthers often confuse too small to
Perception
see
and
with blocked,
perspective.
right? Right, yeah. So perspective and well, yes. So like if a bird flies away, it gets small. Zoom in and you still see the bird. That's perspective, right? If a bird flies behind a
That's
mountain, it's gone.
perception, I think.
Okay. Well, sort of. I want to. I will go back to perspective, but I want to touch on obstruction real quick
Okay.
first. So if a bird flies away, it gets small. You zoom in, you can still see the bird. That's perspective, right? So if a bird flies behind a mountain, it's gone. Zoom in, and you'll just get a close up of a rock from the mountain. That's obstruction. The horizon is an obstruction. not a vision test, right?
I see what you're saying. Yeah.
Okay, okay. So the camera has a nice lens, but it can't bend light around the curve of the planet. So that's where it kind of falls off. So let's go ahead and continue the video and see what they say next.
Okay, we'll go to the next one because I think this one's done.
Oh, okay. Okay. How are we doing so far? If I change your mind, you gotta buy me a coffee.
I'm never gonna change my mind. Hey, I'm a Taurus. That means I'm stubborn as all get out, for one. And number two, I'm just not gonna believe in what they tell me.
But that's why I like you so much.
I know.
You're a critical thinker.
Exactly.
That.
Thank you. That's why I like you too.
There's not enough of those.
Because your views on the elites and all that, but the flat Earth and the globe Earth, we'll get you there. We'll get you there.
Sure.
You're halfway there.
Wait till I show you some of the stuff that you haven't seen yet. Like, take our friend Edward Snowden, right? Most people don't know him. I might have a different perspective on it since I work with him. Wait till I drop that bomb on you. You'll see what happens.
Oh gosh, we'll
As long as Russians
next
can
week,
kill each other.
guys. Next week. Stay tuned. Next week. That's gonna be next week. I'm excited. This isn't a good one.
If NASA indeed traveled to the moon and back,
we'll do this
who
one.
was the camera guy who stayed behind to record them leaving the moon? And how was the footage sent to Earth? The official story says the astronauts left the moon completely alone. But you know, the footage looks like a smooth, steady, well-timed tracking shot. No hands, no shadows, no operator. And that's the part that gets weird. If nobody stayed behind, who aimed it? And honestly, how did that camera send perfect video across 250,000 miles to Earth? So NASA tried to explain that it's a remote-controlled system that magically lifted.
Okay, yeah, this ain't the best video. Let's go on because yes, they could have left a recorder behind on some whatever. Okay.
On a radio signal.
Yo,
Yes, radio
what's up,
signal.
my brothers and sisters? So, I was scrolling and I came across a video where a sister was like,
Okay.
yeah, I believe in flat earth, but do you have to bully me over it? And I'm like, you know what? Y'all globies, boy, y'all be doing the most. But y'all do be on some bully shit. Let me tell you something. Why? Think about it. If, like y'all say, this whole flat earth thing, why does it matter? You know what I'm saying? You guys are just dumb flat earthers, you know, all this extra shit. If it don't matter to you, and we're just dumb, and we don't know what we're talking about, why even address it? Why even come to our threads?
This
Why
ain't
come
that
in our
good.
comment
Let's see what
section?
else they've got.
Oh,
Oh, this is the fittest flat earther. I like him.
It says
We need a
not for
scientifically
educational
literate
use, but
electorate. That's
decorative
why.
purposes only. It's because not only would you never get to where you're going, but if you did, you would add miles upon miles upon miles on your trip. I want you to look at the CBS American School of Air map used in 1943 for flight school. And I want you to look at this. Here is a scale. People always say, where's your flat earth map with a scale? Well, here it is. Not only does it have a scale, it has this funny looking white border with all this outlined mapped terrain. What could that be? What could that be, I wonder? Not that continent at the bottom of the globe. Something else that surrounds it. Now I want you to look at this map. And I want you to look at New York. And I want you to look at the path you would take from New York to Moscow. Okay, let's take a closer look. New
They
York to
change
Moscow.
flight
How's that gonna look on
routes
this map?
so people don't know. They don't see it.
Draw a line right straight across. And notice how it's going to cut through Greenland. Now let's look at what the flight path they show us actually looks like.
Well,
So when you pull up the actual flight path,
I can explain that.
this is what it looks like. They make it so it arcs up to Greenland and then down to Moscow. And notice the distance is actually shorter on their curved line compared to this one if you were to just go straight from New York to Moscow. Why
Yeah.
would that be longer? Think about that. Again, on the flat earth map. That's an actual map that flight schools used to use. Right through Greenland. And I want to show you why their straight line is actually a longer distance. Because this is what their straight line actually is on a real map. the map pilots use, the flat Earth map. It adds distance because you go curve away from it to come back versus going straight across. Now I just want to give you another example of how their curved flight paths from LA.
You seem like you know what he's talking about. Explain.
I do. I'm going to wait for him to finish on my end because I got a little delay. But here we go. Is he ready? Oh,
It's shorter because it's a ball. Oh my gosh. Okay.
So here's how this works, right? You're absolutely right. It's a fucking ball, not a Rubik's Cube. Every map distorts because a flat piece of paper hates the round truth. They got to deal with it. So an oblique spheroid is what the Earth actually is, not a completely perfect sphere. It didn't form that way. Thick at the equator, squished at the poles, like almost like a pear, right? Bumpy as hell, still a globe, not a pizza, right? It's not flat. So Sydney to Santiago, right, is a 7,000-mile trip on the globe. 15,000 plus miles if you're on a flat pizza, because you have to go across both sides. Planes do it in 12 hours, not 48. Math doesn't lie, your map does. So when you take a flat map, right, and you stretch around a globe, that straight line is all of a sudden going to become a curve. Why? Because it's going around Earth, right? Now, if you take a round Earth, right, you put that paper on it, and you draw a line from point A to point B, and then you unround it, and you've got a flat piece of paper, you have a curve. That's why. So when these planes take off, they do fly what's called curved routes. It's called a curved route. That's what it is. They're flying directly from point A to point B, but on a flat piece of paper map, it looks like a curve.
So you're talking about the Gorgarian map, or
so there's a Mercator projection.
Gleason map. Sorry, Gleason map.
Sort of, yeah, right. Because right now most of us see the Mercator projection, right? And the Mercator projection was done for a very specific reason, to put perception in a certain way. So if you notice the scale changes, the higher and higher you go in the latitudes, right? Canada looks huge, but in reality, it's not actually that big. So pull up a regular map and then pull up a Mercator projection. You'll see things will squish. That's why flights to Miami from Chicago, 3 hours, right? You would think it would take a lot longer because it's so far away across the country. 3 hours, and then Miami, Chicago. So
Okay.
Yeah.
I think both views on that make sense.
But if I have to fly, say it's flat like a pizza, right? And I have to go from, say, one side of the Earth to the other. I would have to fly over across one surface and then across the other surface. It would take a lot longer. But that curved route is a shortcut. Why? Because the Earth is round.
Yeah. Okay.
Yeah.
Let's see.
Speaking of, pretty soon you'll be able to take the flight from New York to London in about 4 hours, because there is a new airline company called Boom Airlines. They're making planes right now for United Airlines and Japanese Airlines, right? Their plane will go so high up into the atmosphere, it goes above the troposphere, right? And what happens is when that sonic boom hits, it bounces off the first layer of the atmosphere and right back up. So the people on Earth won't even hear the sonic boom, but it'll actually be able to travel much faster than planes do right now and get you from New York to London in 4 hours.
Lord, how much are those tickets?
We don't know yet. The planes aren't done being built yet. They're working on it. I'm sure they're going to be expensive, probably more than Virgin Airlines. Yeah. About $2,500.
Let's see what else he says on this.
Sure, absolutely. Let me show you that.
Why would we do that? I'll show you. Because on the flat Earth map, LA to Japan is actually exactly straight line. You just fly across. And I want you to notice, where do they cut through? Alaska, and just on the edge of Russia here. Let's go back and look. LA through Alaska, just to the tip, across Russia, and down to Japan. Now is it making sense? Oh, and if you don't believe me, maybe you'll take these guys' word for it.
How long have you been a pilot for?
43 years.
Wow. What shape is the planet?
Flat.
Curvature while we were up there?
Curvature? No.
No, there's no curvature?
I'm going to ask you a question.
Yeah.
I've been flying,
Yeah.
and I've come to the conclusion
Yeah.
there is no curvature. I never allow for curvature. There's no way there's curvature. We're round and flat, aren't we?
Definitely.
We are, aren't we?
Flat as
Thank
pancake,
you.
mate.
Flat as a pancake, mate.
And the outer ring is south,
Yeah.
and so north must be in the middle, correct?
Possibly.
That
Yeah.
would be the only way that a
Yeah.
magnetic compass works on a flat plane.
Might be onto something there.
Yeah,
Might be
but
onto something.
you're not having me on.
No, no,
We're round and flat,
Flat
aren't
as a
we?
pancake, mate. Yeah. There you go.
Thank you, man.
No worries.
You made my day.
So again, this is on the
Pilots are saying the Earth is flat. What you got to say for that one?
Okay. All right. Let's see here. Okay. Yep. So pilots, right? Why do planes fly in curves? They don't. They fly straight. That's why the pilot is flying straight, right? Take a basketball. Take a string.
Well, of course
put
you're
it on
going to
any
fly
piece of
straight.
basketball. Right. But take that piece of string and just put it on the basketball somewhere. 2 different points. It looks straight, right? Following this flat. It's flat against the basketball, so it is straight, right? But you know that there's a curve on the basketball, and that string is following that curve as it's flat against the basketball, right? Correct?
Okay.
So now, let's say you take that basketball and you flatten it, leaving the string exactly where it is, right? Is it going to be in a straight line or is it going to be in a curve?
I don't know. I'm going to have to try this experiment. And I don't think I got a basketball.
Okay. Let's see here.
He comes prepared. You've got wake up early on the morning to get to 80,000 feet to see the. Okay. I'm not a early morning riser, so that would be hard for me. What you got? We got a tennis ball.
Cut it in half. Yeah.
All right.
We owe my dog a new ball, by the way. She's going to be so unhappy. So, now I cut a straight line in this ball, right? From here to here, it's a straight line.
Okay.
If I was to flatten this ball out, notice how from this perspective, it's not a flat line anymore. It's curved.
Okay.
But when it's this perspective, it's just a flat line. That's how you see the flat line, right? So because the curve at a 3-dimensional plane, right? So if the Earth was flat and it was in a 2-dimensional plane, all you would see is that one line. But when you look at things from a 3-dimensional plane, you'll see it really is round. So it's about matter of perspective. Hope that helps.
But pilots know this, right? And they're still saying that it's flat.
Okay, so if a pilot goes up, say, 20,000 feet, right? He's always going to be 20,000 feet from the Earth's surface, right?
Mm-hmm.
If he was to say, keep flying in a straight line, and the Earth wasn't round, he would just basically go off at a vector away from the Earth's surface, right? So if he was going to fly in a straight line, he would follow this curve. If it was flat, he would just go straight away.
It's because our continents are around the North Pole, so they do fly in a curve, but it's really flat because North America's here, you've got the North Pole here, and then you've got Russia, and then you've got China. Like, we go all the way around the North Pole. That's why it works that way.
Sort of. So, okay, let's say I take a drop of water and I put it on this ball right here, right? And the water drips off. Is it going to, like, drip off this way, or is it going to drip off down the side of the ball?
Down.
Right. Same way the plane is flying. It's going to be hung against the surface, but at 20,000 feet.
Brian. Oh, my gosh.
Big balls, ball
Yeah, there we go. We'll agree
bad balls,
that it's just
all good balls.
big balls, ball bearings, high balls, low balls, good balls, bad balls.
Brian and Victoria are very smart people, it seems like.
He'll thank you later. All right, let's see what else we got.
Because you know how I figured it out? What's 1 times 1?
2.
1 times
Wait,
1 is
1 times 1 is 1, yeah.
To multiply means to do what?
Especially if it gets to be a high ball or speed ball.
To make more, right?
Yes.
Increase a number,
Yes.
multiply.
Oh,
Yes.
this guy.
How
I
can
know
1
this
times
guy.
1
I never
equaling
wanted to
1
watch in Chicago.
be part of the multiplication table? It fails to satisfy the term multiply. It doesn't multiply. Does it? What's an action times an action?
You got some weed.
No, I'm asking you. Honestly, I'm asking reason. Reason. I want you to reason.
I don't know.
What's an action times an action? A reaction,
Oh, yeah.
right?
Yeah,
Have
Okay.
you ever seen an action times an action without a reaction? Have you? No. because equanimity is the currency of the universe. There's always an action times an action having a reaction. So how can 1 times 1 equal 1? How can A times B just be A and not B? What happened to conservation?
Terrence, these are late night conversations.
These are no. These are. This is the
It's late
beginning
night for us.
of our understanding. It should fit. What kind of calculator you got? What kind of phone you got?
iPhone?
Okay.
I want to see where he's going with
Whatever
this.
the new.
No, go to your calculator. Go to your calculator.
All right. Go to
Go to your calculator.
Yeah, I
you
got
do too. You got iPhone?
What are we doing?
I want both of y'all to do two
He's going
separate things.
somewhere.
Do the same thing to start
I
with.
wouldn't want to go
Turn
to
it to the
Lindsay,
side.
Okay.
All right. Now I want you to both hit the number 2 that the whole calculator show up.
Hi, Mike.
Hit number what?
Hit the number 2.
Welcome.
Two.
Go to the square root. It is the second column from the left, third row. It'll have that squiggly
Yeah.
thing.
All right.
You get
1.4.
1.414213563737095.
Holy
now
crap.
I want you two to do 2 separate things now. 2 separate things. I want you to multiply it by 2, hit times 2, equal, don't you do it.
Okay.
And I want you to hit x to the third.
Where's he going?
X to the third, it's going to be... the
Times
third-
3?
No, x to the third.
Oh, X. Oh, okay. I see it. I see it.
X to the third.
Yeah, I got you. All right. 1.1.
No, you didn't hit x to the third.
Yes, I did.
If you hit x to the third.
Oh, I'm sorry. You're right. You're right.
So
I
go
did
back
that.
again.
Okay,
You
so
keep
now
yours where you are.
Yeah, I'm
2,
good.
2
square root,
square root.
and hit x to the third.
All right. 2.82.
2.828, 4271, 2174, 6190. The same value you got
Yeah.
by multiplying it by 2.
Yeah.
And he just cubed it. Divide it by 2 again. Both of y'all. Divide by 2.
Divide it by 2.
No, divide by 2. Hit equal. Now, cube it again. Hit x to the third.
Yeah.
You see that loop?
Yeah.
That's saying x cubed is equal to 2x, which is equal to x plus x. That's an unnatural equation. That's a mathematical fallacy. And that's the beginning.
I
of
know
the
where
math.
he's going with this. Okay, so y'all like to explain the flat earth with mathematics, correct? Well,
Yeah, I
not
can
all
explain it.
math
Okay.
is mathing up, though.
Well, let me help you out here. So, Mr. Terrence, I love you. You've been on the show Empire a few times. We recorded it at Sunup. I arranged it for you. I love you. You're a great guy. I would like watching you wear your little homo outfit around Chicago's River North Gold Coast so people couldn't figure out who you were, but that's what he was doing. So, bro, you did discover new math, bro. You discover what happens when you snort bath salts and try to fuck a calculator. So, 1 times 1 equals 2 is the dumbest shit ever spoken by a man wearing a $40,000 Iron Man. Seriously. Multiplication is just repeated addition. You beautiful lunatic. 1 times 1 equals 1 group of 1 thing equals 1, right? 1 times 2 is 2 groups of 1 thing equaling 2, so on and so forth. If 1 times 1 was actually 2, then 1 apple times 1 apple equals 2 apples. Congrats, you just invented free lunch and got the entire IRS hunting your ass for infinite money glitches. Every dollar bill, every bullet, every round in your clip, every inch of your dick size, all on 1 times 1 equals 1. Right? The moment you say 1 times 1 equals 2, bridges collapse, GPS dies, your bank account turns into a pumpkin. You didn't break math, Terrence. Math broke you, right? Again, I love you, math, Terrence. It's just not how it works. Now, please sit your $2 ass down before I make change. And let me continue explaining this real quick. Multiplication is not addition. Howard is confusing times with plus. Addition, 1 plus 1. So, right, you have $1. I give you another $1. That's $2, right? Now, multiplication is 1 times 1. You have $1. I tell you to count that stack 1 time. You still just have $1, right? Multiplication describes 1 times 1 means 1 group of 1. You don't magically spawn another group because you call it multiplication. That's not quite how that works. You usually confuse the name. So the punch in the face proof, right? Let's make it physical. If I punch you in the face 1 time, how many times did you get hit? Once. According to Terrence, if I hit you just once, you should feel 2 punches. Trust me, you only feel 1. That's the reality of 1 times 1.
Oh, is that what he was saying?
Yeah, basically, I think.
Okay.
Or maybe he just, yeah.
Well, let's see what else.
In math, the number 1 is the identity of it. It is a mirror. Anything multiplied by 1 stays itself. 5 times 1 is 5. 100 times 1 is 100. So on and so forth. Howard thinks multiply means growing it. It doesn't mean that. It means scaling. If you scale something by a factor of 1, you haven't changed the size. You've just wasted your time measuring it.
Okay.
All right.
So mathematics, you waste time. Okay.
Well,
Just kidding.
if you
I'm
do it wrong.
kidding.
Yeah, if you do it wrong.
Let's see what Flat Earther says.
What's next?
Fittest Flat Earther.
I just got done having my mind blown. So if my mind is blown with what I just experienced, you better hang on to your seats. Let's start with this 34-mile.
This is going back to the horizon thing, our perception
north
and stuff.
to south. And check out how it looks. Let me first show you that over the course of 34 miles, there should be approximately 770 feet of curvature.
Okay.
And from one end of the 34 miles here, straight, straight, flat, flat, straight, straight, flat, 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 flat,
okay.
flat, 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 straight, flat, to the other end of the 34 miles. Where's that 700 feet of curvature?
Yeah.
But I haven't even begun. Because this morning I was walking that same beach with a sunrise backlighting what appeared to be buildings in the very distant background. And I thought to myself, no way. Because the angle of those buildings was pointing right to Charleston, South Carolina. And even I, as the person I am, thought, no, couldn't be. Could it? I couldn't possibly be seeing Charleston, South Carolina from 193 miles away, right? I mean, 193 miles away at an observer height of 6 feet would give you 24,000 feet of curvature. That would have to be some pretty nifty refraction. That would have to be refraction showing me a mirage. Over 4.5 miles tall, I mean, that's some pretty impressive light refraction. Because although blurry, because I didn't have my trusty Nikon camera,
there.
when I compared what I was seeing to Charleston and their skyline, and when I literally asked the locals there what that was, they said they didn't know. But it seemed to be there only in the mornings, when the sun is backlighting the buildings, so you can see.
Yeah.
And when you do an overlay, especially with this building and this building, they seem to match pretty well. When you add up all the pieces of the puzzle, like literally facing directly at those buildings, and the fact that I was there early in the morning to catch the sunrise backlighting those buildings, and when it matches here, even down to that little tiny hump and that little tiny hump, and the overlay seems to match pretty darn well as well, well then at a certain point you really
And that's a
really
CGI
gotta
image
ask
right
yourself
there.
if you really live on one of those. But of course this is all for entertainment purposes.
They have to say that or they'll kick them off TikTok. So what's your response to that, Mr. Type? Let's type it up.
Sure, I got the delay, and I will.
I love that. I love that you like do that.
Okay.
How did the sun rise in the north? So basically, I'm going to have to find you an image of the flat earth, and then it'll make more sense. But basically, the sun goes around the continents. It goes around like a clockwise around the north
The sun's
pole.
going around us. Okay.
Yeah.
Okay. So it goes around the flat surface, and then it goes around the other side of the flat surface, right? Is that what you're saying?
No.
No, okay, say that.
Go ahead and say what you were going to say, and I'll pull up an image.
Okay, so the Earth is flat. Okay, I'll say. So you spin on the beach like a drunk ballerina and scream, "It's flat, no curve." Which is what this guy did. Bro, he's 5'8" inches tall, right? Looking at a 25,000 mile ball, right? That's like an ant crawling across a basketball, yelling, "I don't see the curve," right? So the curve is only 8 inches per mile squared. At 3 miles out, their naked eye horizon, the drop is only like 6 feet. So that's why he can't perceive it. If you stand on the beach, the horizon equals roughly 3 miles, right? Curve hidden below the eye line. So if you get your ass up 100 feet, right? If he stands like 100 feet higher, the horizon jumps to 12 miles out because his perception is going to grow from that distance. That's why he said we were roughly at around 80 feet, right? So let's say I'm at Lake Michigan, right? And I see Chicago from Indiana Dunes, right? Sometimes I don't, sometimes I do. Hot air over cold water bends light like a motherfucker, right? So it's like a superior mirage. Chicago skyline floats 60 miles across the lake like a ghost. The cold air layer flips it. The mirage The city vanishes behind the curve again, right? It's literally the atmosphere flexing light over the curve. Same reason the sun looks flattened at sunset, right? You didn't debunk the globe. You just like discovered basic refraction. That's what he did. Right? We talked about refraction earlier, and this is a perfect example of that. So, yeah.
Okay. Refraction, light
Yeah,
versus
think of the atmosphere like a funhouse mirror, right? So that's why it causes that perception of the curve, right? If the Earth was flat, you would see like every city every single day. You wouldn't. You sometimes appear and not, sometimes not, right? So,
I'm gonna have to take that Streamlabs thing off. It's saying refrain from sending long messages. I hate that. I'm gonna have to. I'm so sorry, Mike. I'll check that off. I'll just have to figure out how to take that off.
what we have to do is we need to fly somewhere and be in the same studio at the same time, so we can just do this like pros, you know.
Yeah. That's what. Yeah,
We'll get you there. We'll get you there.
we'll get. Yeah.
If we don't get stuck in a CIA like dark site first for some of the stuff I'm going to tell you for next week.
Oh, Mike said he's been a flirter since spring of 2014. Wow.
You know, congratulations, Mike. I really like that loyalty you have there. I think it's great. I hope you can change your mind.
Don't
because
listen
I
to
really
him.
think that this country needs a scientifically literate electorate. You know, we want you guys to know everything there is to know so you can make informed decisions. I do because I care
Yeah.
about you, man.
You're not gonna change our minds because we're critical thinkers, right?
I like critical thinkers. I just want them thinking critically about these flat earthers too, and why they're wrong.
All right. So I pulled up a flat Earth map thing.
Okay, great.
Let's see if I can get it to pull up here.
Or if you send me a link, I can click it. And make it nice.
Yeah, let me send you the link because for some reason it's wanting to be a bitch about this. Copy. And I'll send it on Discord
Sure.
in your DM. There you go. If you can media share that, that would be great. Let me make that possible for you.
Let's do this. Actually, I'll make it take up my window, and you can change the size of the window.
You think you can do it already?
Yeah, flat Earth, right? Yep. Okay. Flat Earth.
Here, let's do that. Media share. There you go.
Okay. See me?
So pull up that image right next to it. The image.
This one right here?
Yeah. Click that. Okay. So, that is the flat Earth. So, as you can see, you've got the sun and the moon, and they are going clockwise around the North Pole. You've got the United States right there at the bottom. Right there at the bottom. And then, yeah. So, when the sun... So, basically, you were asking why is it... The sun... Yeah. Because it moves like that. What about the sun? It just a big burning flat tire of a sun. So the sun, it says in the Bible that it was created to light the earth. So I think that it's just a spotlight. I don't think that it's a big ball of fire. Because wait. Let me ask you this. Don't you need oxygen to have fire exist? There's no oxygen in space. So how is there a big ball of fire in space?
You don't have to have oxygen to exist. What you need is a fuel source, right? Like hydrogen, for example, will catch fire. And that's what the sun's mostly made out of, right? As a matter of fact, if you take a look at the periodic table of elements, the number one element at the top is what? Hydrogen. Why? Because it is the most abundant element in the universe. Everything starts with exactly one proton, right? As elements grow and things begin to fuse together, nuclear fusion, right? One proton plus two protons plus three protons. Eventually, we have other elements forming, which is exactly what happened when the Big Bang happened. Things came together, they fused together, and now we have other elements like gold or copper, right? So hydrogen is the very first one. That's why it is the most abundant element in the universe, which is why I think we should power our cars that way, because we'll never run out of hydrogen. It'll be cheap. We won't have to spend a ton of money like we do on gas. It's just good for everybody. Now, from this map, right? I'm going to zoom back in here for you. It appears as if the sun, right, is here, and the moon is here, and they're traveling around the circle. But if you notice, this is not a flat Earth. This is a concave dish.
That's true. That's true.
Right.
I'm not saying it's completely flat. I'm not saying it's like a piece of paper, but it's not a spinning ball.
Okay, so let's say the sun is exactly here inside this concave thing, right? And it's broadcasting its light down here on the Earth's surface, right? It would broadcast that light all the way across this portion of the globe right here, and we would see. No, why not? Why not?
No, light. Okay, so if light traveled like so light like diminishes, right? You can't like at a certain point in time you can't see light anymore. By the time by the time it's like if it shines, I don't know how big the sun is either. Like I really don't, but I know that it's not bigger than the Earth. Oh, okay. Cool. Yeah, that's our Discord. So, like when it's shining right over the United States, you're not going to see it anywhere else because by the time that light gets to you, like if you're in China or somewhere, you're not going to see it. Does that make sense?
Sort of. It's mostly because it's being blocked by an obstruction. If we're not ground, and I can only see spark.
Maybe.
Okay, so for example, if a light photon starts traveling, and let me see if I can explain this to you real quick. I want to make sure I get the numbers right. So the speed of light is really, really fast. So light travels at 186,000 miles per second, right? So if the light goes off in the middle of the universe, right, and I am 186,000 miles away, from the time it went off to the time my eye actually perceives it is a whole second, right? It doesn't happen instantaneously. That light photon has to travel all that distance before I can see it, right? A traveler moving at the speed of light around the equator, right? So, okay, make sure it's good. I'll try to explain it in a way that's going to make sense.
Mike says the sun size on that map would be. Why does it do that? Oh my gosh, Streamlabs, stop. I'm going to have to take this off. Can you send that again, but in 2 separate comments until I fix this? I'm so sorry, Mike. I don't know how to fix it right now. Crap. Timestamps, reactions. But you were saying... why is it doing this? I am so sorry, guys. The Streamlab is not letting them post their comments. Okay. So Mike says the sun size on that map would be about the size of a dot or a pixel. Those sizes you can see on maps are exaggerated and for the demonstration purposes only. Victoria says, but on a normal day, people in northern Canada see the sun at the same time as someone in Chile. Do they? I didn't know that.
So what did she say again? I'm sorry. The sun, Chile? Santiago, Chile to Sydney is a 12-hour direct flight. Sure.
Oh, and that your share is still over your face, by the way.
Oh, gotcha. I'll fix that. Actually, I kind of want to leave it up for a second just so I can take a look at it while I'm doing it.
Okay.
So, the Australia problem. So, you look at Australia on the map, it looks like a squashed pancake, stretched out twice as wide as the United States. In reality, Australia is distinct and compact. The map works fine near the center, North Pole, but further out you go, the more it distorts. Right? By the time you get to the edge, the map is stretching. Land masses like cheap taffy. If Australia actually looked like that, a road map from Perth to Sydney would look like it would take a month. Right? The impossible flight thing that they talk about, Santiago to Sydney. On a flat Earth map, to fly from Australia, South America, you have to fly all the way near the North Pole and back down. It would be a massive U shape, right? Because you have to go all the way around, right? If it's flat. In reality, Qantas flies from Sydney to Santiago nonstop in about 13 hours. They fly over the entire Southern Ocean. If the flat Earth map were real, the plane would need to fly at Mach 3 or carry 3 times the fuel. The math implies that the plane teleports. It doesn't. In December, Antarctica gets 24 hours of sunlight. The sun never sets, which is kind of what this map is showing here, right? So on this map, the sun is a very tiny spotlight circling the equator. Explain this to me. How does a small spotlight in the middle light up the entire outer ring, the ice wall?
It's not the outer. It's they flipped it on us. And Mike, I need your help with this because it's very complicated to explain. Why is there a 24-hour sun in the Arctic? But however, I think they switched. Like they're north is south, south is. Do you know that they're actually saying that now? Like on the media.
The magnetic poles of the planet.
Mm-hmm. Like, yeah, it's weird, but I think it's got something to do with that. So Mike says the sun goes in circles, yes, but also it corkscrew spirals. That's right. Higher when in the north and lower on the horizon when in the south. And this is why the sun does not have to change speeds throughout the year. That's correct. So the sun and the moon kind of like go like this. Like it's hard to explain.
So they're circling. They're both circling around the Earth, and like they're pulling on each other, right? Like
do what now?
Like they're circling around the Earth at opposite ends, right?
Yes.
And basically pulling at each other, right? Okay.
Yes.
That's what you're saying.
Yes.
I just want to make sure I understood that correctly.
Mm-hmm. Yeah, it deletes your long messages, by the way, Mike. If you can still see them, that's great. Hopefully you can still see them on the actual live. I'm going to have to take that stupid thing off. I don't even know how it's on there. Victoria. I don't want to overlook you, Victoria. We saw the post in the stream, but stream. Oh, okay, yeah. I'm going to have to fix that. Thank you, Victoria. But yeah, we've already been live. Like on this second live, we've been live an hour and 13 minutes. So we're going to close this out. You got anything else you want to add, Godfather?
Let me do this. Let me take this last one down real quick.
Okay.
So this is Orlando Ferguson's map. The Bible says 4 corners. Ferguson drew a square Earth with a weird bumpy donut shape in the middle to fit the scripture. The roulette wheel. Look at the water. It curves up like a skate ramp. Okay, Physics 101, water flows down. On this map, sailing in South America means sailing uphill. That's not a map. That's a roulette table at the Bellagio, right? Okay. The metaphor failure. He drew a square because the Bible said 4 corners. If I say I'm hungry enough to eat a horse, do you bring me a saddle? Stop building blueprints out of poetry. It's just he's taking it way too literally. The Bible was never meant to be taken literally. I've read the Bible. Right? Last piece. Angels aren't GPS. Zoom in. There are literal angels in the corners holding back the way. If the scientific model relies on guys in togas using magic, you aren't doing science. You're playing Dungeons and Dragons. Right? The verdict of this map. This isn't a map. It's a religious fan fiction. That's it.
Streamlabs keeps deleting their comments. I'm going to kill Streamlabs. But I saw what you said. If you could just repeat that. But yeah, like he said, and like I said earlier, the north at the North Pole is very high, and then it corkscrews down towards the south. Victoria says, but on a normal day, people in northern Canada can see the sun at the same time as someone in Chile. Oh, okay, I already read that. That's right. Did it delete all y'all's
Well,
content?
that's
What
because
the
they're
heck?
that's also because Chile and Canada are both in the Western Hemisphere. That's why. It faces the west, and as it slowly goes around. Yeah.
I'm so sorry, Mike. I will have this fixed next week. I promise you. And is
Well, this
low
area
in the
is
sky when going around the outer edges, aka Antarctica. So it starts high and then goes low in the sky when going around the outer edges. The sun.
Well, the Earth is also at a tilt, right? It's not Earth is
No,
not straight up. No.
it's not tilted.
Yeah. Sure it
It's
is.
not on an axis. It's not, no. It's like, that would mean it would have to be a ball, and it's not a ball.
It is. But see, like, if it is, then it makes his theory wrong, doesn't it?
We'll get him, Mike. We'll get him one of these days to convert over. You too, Victoria. You got to join us over here on the Flirther side of things.
Let's say this is the sun, and this is the flat Earth, right? The sunlight would be shining on this flat surface across the entire surface.
But it doesn't go around like that. I mean,
It doesn't.
I
Let's say it
mean,
goes around like this. It's still visible from the surface. If I'm standing here, this
it's
ball is still
inside the
visible.
firmament.
Firmament. Sorry, explain that. I'm sorry.
The firmament is the
So
dome
that curve.
that's
Uh-huh.
over us that we
Okay.
can't, that doesn't let anything out in space.
So the dome, this dome would be round.
This dome, it's like, just envision a snow globe.
Mhm,
It's like that.
Okay, a snow globe, right? So a globe around surface.
A
Okay.
snow globe is, yeah.
I'm just
okay.
saying.
I
You're
know,
making
I
light of
know,
it,
I
don't
hear
you
you. Okay, then in that case, a snow half globe.
Okay. I take a string to this ball, right? And I start whipping it around my head. It's going to go in a circle, right?
Uh-huh.
Anywhere from the center, I can see that ball above me. So that is the same way the light would move. The light would be on the surface the entire time it's spinning. And the other side of the surface, the Australian people on the bottom, they wouldn't get any light, right? And then we'd have a sunset, we'd flip over, and Australia would have all the light all the time as it's spinning.
You're
So we wouldn't get
wondering
light.
why there's a
But
24-hour
Earth
sun
doesn't flip
still.
over. Well, it's because it's going around the Earth. And so we have a 24-hour sun because we see it sometimes, and sometimes we don't, because the globe turns. Just like sometimes we see the moon, sometimes we don't.
Help me out here, Mike. Oh, gosh.
So like if you're standing perfectly straight, right? If you're standing perfectly straight and you don't move your head at all, you're just looking one way. If I start doing laps around you, once I'm behind you, you can't see me. Why? Not behind you. Your eyes don't see every direction, right?
The hemisphere is what you say the dome is?
Okay. Hemisphere means half a sphere, right? So that's half of the globe.
Right, yeah.
So yeah, the half that the sun is facing can see it. The other half can't. That's why we have time zones, right? So every hour that the sun is rising in one place, it's setting in another. That's why you see the sun an hour later than I do, or 2 hours.
It's got to do with the way it,
Goes around.
yeah, like the corkscrew motion.
It's still going around, right? So like, you can't see this side of the ball, correct? Because it's facing me, not you.
Good
that's
night.
the
Have a
sun.
good evening. Yeah.
Well,
It's hard to explain. And we
I'll get
we
you
have
there.
to
I'll
wrap
get you
things
there.
up here, but
Sure.
the point
Thanks for
being,
your
it
everybody.
is.
Sorry for the technical difficulties.
No, yeah, sorry about the technical difficulties earlier, but this has been a very long stream, and I'm actually proud of it. Thank you guys for sticking with us in the chat. I had fun. Next week is going to be on Hollywood, the secrets of Hollywood. I'm excited. So
We'll get to the
yeah,
Hollywood stuff next
but
week.
the point is, the Earth is flat, not a globe. So yeah, I'm kidding. I really don't know what the shape of the Earth is, but I do know that it's not what they say it is.
It's almost like a pear. Right?
It
I'll think
might
about it
be.
better
I just, yeah, don't believe everything the government tells you. But yeah, until next week, guys, we will be live at 10 p.m. Mountain Standard Time. Go to sophfuckup.com, send in your AMAs for next week. And yeah, check out our store. There's a few new merch items on there. Awesome. Thank you for subbing.
Have you seen the new store?
Huh?
Have you seen the new store website?
Last night? No, I viewed it before last night. Did you fix it up?
I changed, made a few changes to it.
Ooh, I'm going to have to look. Okay. All right. I will see